All right, we are going to talk about the receptor in more detail. So this is our safety pin cycle. We know that the brain and spinal cord is going to be your central nervous system. Your central nervous system includes interneurons, so anything above this line. Now we could go in great detail about the brain and spinal cord at this point, spinal cord anatomy or the divisions of the brain. But we know that the peripheral nervous system is going to have spinal nerves, and a nerve is a bundle of sensory and motor neurons. Cranial nerves are also going to have neurons. They can be sensory only, motor only, or mixed, but all spinal nerves are going to be mixed. We know that there are 31 pairs of spinal nerves that come off of spinal nerves. Cranial nerves, we know that there are 12, and those are Roman numeraled. We've seen ganglia multiple times for the posterior root ganglia, and now we've covered a plexus. Now, the peripheral nervous system has 3 subdivisions which all control different effectors. Your SNS, your ANS, and your ENS all have different effectors. Now, where we haven't really gone into great detail is this side of our safety pin cycle. So, what we're going to talk about now are the types of receptors that detect changes in the body. So, when we talk about receptor, we are going to have to remember that we have general senses, which you should be able to tell me what general senses are, versus special senses. Receptors are going to be in the body, which is going to be general senses, but you're also going to have special receptors that help us with special senses. And when we say receptor, the receptor is going to detect these senses. It's going to be for detection. Now, we classify receptors in many different ways. So we're going to have a list of basically general senses and special senses that we need to understand which receptors come off of it. So I want to make a full list of general senses. You should be able to start listing general senses without my help. So, touch, pressure, vibration, itch, tickle, hot, cold. These are senses that we can feel. We can feel pain. And another one that we can feel is what we call proprioception. This is a new one that we've never talked about. So proprioception is a type of general sense that is basically going to be awareness of limb and joint location. So these are all general senses, but proprioception is a new one. There can be a couple more maybe I could think of, but right now I can't. So, special senses. When we talk about special senses are going to have receptors that are confined to the head, so there's always only 5 special senses. That would be vision, taste, smell, hearing, and equilibrium. Now, most of your special senses are going to be controlled by your cranial nerves, because cranial nerves go to the head and neck, where most of your special senses are located. The receptors are going to be located in the head and neck, where general senses are called body senses. The receptors that we're going to talk about are going to be all over the entire body. So these are body or somatosensory senses. So we're going to talk about receptors, a lot about receptors. So we really haven't made a list on receptors, and I'm keeping it blue because receptors are going to be what sends sensory neurons. We're going to have a lot of different receptors that we're going to list. So now we're going to be given names to these receptors. All right, the first thing, when we classify receptors, they can be microscopic structures. Only seen with a microscope. Now, microscopic structures are going to include free nerve endings. Free nerve endings are just going to be plain old neurons. Nothing fancy with that. So, free nerve endings. Basically, you're going to have a neuron with dendrites and an axon. That's a free nerve ending. The difference between a free nerve ending and the next type would be what we call an encapsulated neuron. Anytime we say an encapsulated neuron or a receptor, we basically mean that it has a corpuscle. Corpuscle means that it's encapsulated. So you could have the same type of neuron. I'm using bipolar as my example. Bipolar neurons. Now, encapsulated basically means that it's got a capsule around it. Especially around the dendrites. That's the capsule. Encapsulated. There's a capsule surrounding it. We call that a corpuscle. All right, the second way we classify receptors is how fast they adapt. Adaptation is how fast they respond. We have fast and slow. Receptors. Smell is very fast. Within seconds, your smell is going to drop down by 50%. So we would say that is a rapidly adapting receptor. And it can also be slow. Some receptors are very slow. So these are just going to be fast versus slow. Adaptation. All right, the third thing is pretty self-explanatory. Location of the receptor. When we talk about location of the receptors, we're going to say exteroreceptors versus entero. So extero is external, entero is internal. External is close to the body surface. So we could also say superficial. Entero is found in the body interior. So these are going to be deep. That's the location. Okay, the next type is the type of stimulus. Detected. We have a lot of these. So, the first type of receptor that we're going to talk about is thermoreceptors. Thermo means thermal. Thermoreceptors. These are going to detect changes in temperature. So we have two types. We have cold receptors and we have hot receptors. All right, the next one I want to talk about is called chemoreceptors. These are going to detect changes in concentrations of chemical substances. I have two examples for here. The first one would be blood concentrations. Blood concentrations can be different levels of various substances like calcium, oxygen, anything that has a molecular formula. Blood concentrations. Now, we also are going to use these in special senses. For taste, taste is involving chemicals. Also smell. Those are your chemoreceptors. Now, photoreceptors. When you use the word photoreceptors, so chemo, chemical, thermo, thermal, photoreceptors are going to be used to detect light. So for the human, these are only in the eyes. We're going to learn that the photoreceptors are called rods. Rods are going to help you see in dim vision. Or dim light. These are going to help you see outlines of objects. The next one's cones. This is going to be bright light conditions. This is going to help you see colors of objects. Those are our photoreceptors, which are in the eye that we're going to learn about. Okay, the next type of stimulus is called nociceptors. Nociceptors are going to respond to noxious stimuli. Noxious means annoying. Examples of noxious stimuli includes pain and tissue damage. That's a noxious stimuli. Okay. We're still continuing the types of stimulus. Now we learn proprioceptors. Well, we have two types. Proprioceptors are going to detect limb and joint movement. So we have 2 proprioceptors. So some of these we have more receptors that go with it. Thermoreceptors, hot and cold, photoreceptors are rods and cones. So for muscle or proprioceptors for limb and joint movement, this one's going to have receptors called muscle spindles, which are located in muscles of the limbs. That's a type of receptor. These are going to monitor muscle length. And when we say muscle length, what we really mean is we're going to monitor how much it's stretched. So remember, spindle for stretch. Okay, the next one is called the Golgi Tendon. The Golgi Tendon is obviously found in the tendons. These are going to monitor muscle tension. Tension for the Golgi tendon and stretch for the muscle spindle. Now, mechanoreceptors. These are going to detect mechanical forces that deform the shape of the receptor. Now, these are mostly going to be found in your skin, but they're also found in other places. So, there's different ones in the skin. So I really need to cover the skin. When we talk about the skin is going to be in 3 layers. So I'm going to talk about all the mechanoreceptors, because your mechanoreceptors are going to be located in, a lot of times, your skin. So when we talk about skin, there are 3 layers of skin. So mechanoreceptors are going to deform. So these are really going to be involved with touch. Mechanoreceptors. The outer layer of your skin is called your epidermis. Now the next layer of your skin is called your dermis. And then the lower region is called your hypodermis or subcutaneous region. Now your subcutaneous region is going to be full of adipose and fat. So this layer is your subcutaneous layer. The 3rd layer. I'm just going to draw circles here. This is our skin. Epidermis is the outer layer of skin, dermis is the middle region, and then the 3rd layer is called the hypodermis, also called the subcutaneous. Cutaneous means skin region. All right, now we're going to have a couple encapsulated neurons. So I'm going to draw these out and then I'll go through them. We're going to have basically neurons that are right under the epidermis. We're going to have some neurons that are deep These are going to be encapsulated. Now we're also going to have some that are within the epidermis. So we have one underneath the epidermis. All three of these are going to be encapsulated. So encapsulated means that it's got a capsule around it. So we're going to have some right here, which is underneath the epidermis. And then you're going to have one at the bottom that's got several layers of capsules. You're going to also have hair. This is your skin. I'm going to draw a hair. The word for hair is pili. Right now we're not learning that. This is a hair. So we're going to have one receptor that's going to be attached to it. There's one I'm missing, but I don't know which one it is. So, we have three that are encapsulated. These two are the same. And I'm just going to draw the other one right here. Alright, these are all mechanoreceptors. Now, when you touch skin, when I touch my skin, it's deforming it. So your epidermis is the outer layer of skin, your dermis is deep, and then your hypodermis is the deepest. So we're going to talk about mechanoreceptors, and most mechanoreceptors are going to be in the skin. So these are going to detect, examples would be touch. Spell touch right. Touch and stretch. So when we talk about touch, we have light touch and we have deep touch. Now the ones that are just under the epidermis are called Meissner's tactile corpuscles. Corpuscle means it is encapsulated. So that one is right here just under the epidermis. Now, the one that is in the epidermis are called Merkel cell fibers. That one is in the epidermis. Okay, the one that is deep in the subcutaneous and deep to the dermis is going to be lamellated. Pacinian corpuscle. This one right here. Okay, the one attached to your hair is called the hair follicle receptor. And the one that's right here by itself is going to be called Ruffini Endings. Most of these are named according to the scientists: Ruffini, Meissner's, Pacinian, Merkel. All of these are named according to the scientists that found them. All of these are going to be mechanoreceptors. So when we start, we're going to start with Merkel cell fibers. These are all mechanoreceptors. Okay, by looking at Merkel cell fibers, we would say that these are encapsulated. These are going to detect discriminative touch. When we say discriminative touch, and we're talking about the Merkel's fibers are going to help you feel the texture of objects or the shape. So an orange. So these are located in the epidermis. So when you feel something, that would be Merkel cell fibers. Now the one right underneath it, called tactile Meissner's corpuscles, corpuscle means it's encapsulated. These also are going to do discriminative touch. But more than that, these are going to detect light touch. So if something barely touches you, then you're going to say that tactile Meissner's corpuscle was used. Now, let's go this way. Ruffini Endings. When your skin is stretched, your Ruffini Endings is what's used. These detect stretch in your skin and overall movement. Okay, your hair follicle receptor. This is going to detect when your hair bends. Some people love for their hair follicle receptors to be fired off. It's like, feels so good to them. Okay, the last one is your Lamellated Pacinian, for the guy who named it, Corpuscle. I like the names of the scientists. I feel like if I found something, it'd be kind of cool to put my name on it. Now these are deep, and corpuscle means it's encapsulated. I don't have room for that, but because these are deep, these are going to detect heavy pressure. So when someone gives you a deep massage, Lamellated Pacinian corpuscle will fire off, but it's also going to detect vibration. So these are all the different types of receptors that we would add to our safety pin cycle, and they all detect different things. We just haven't really been giving a lot of names to these. So classification of receptors, the first thing that we talk about is it encapsulated? When we say it's encapsulated, there's a capsule that closes it in. So we do have a couple of encapsulated receptors that we learned about. We haven't learned a lot about adaptation. Location of the receptors. The ones in your skin are exteroreceptors. Something that's in your stomach would be enteroreceptor. So you could classify a lot of the receptors that I'm giving you several different ways. So know the differences between the stimulus and then those further receptors. So thermoreceptors is going to be broken down into cold receptors and hot receptors. Then you have chemoreceptors that detect concentrations and chemicals. Photoreceptors are going to detect light, which is called rods and cones. So you literally could say A, B, C, Nociceptors, D, we kept going. Proprioceptors would be E, which includes muscle spindles and Golgi tendons. And then F, mechanoreceptors. There's a lot of these. So for each one, there's subclasses. You can do Roman numerals for those. Some of them are just straight up to the point. Mechanoreceptors are Merkel cell fibers, tactile Meissner's corpuscles, Ruffini's endings, hair follicle, and lamellated are the ones that I've covered. So these are all the different types of receptors, and basically these receptors are detecting changes in the body, which sends sensory neurons to send information up to the brain to be processed. And if we need to do something about it, we'll send motor neurons out, and we'll control different effectors by different peripheral nerve systems, or PNS systems.